Okay, so we had reached to this point, total internal reflection. So I believe so that once you people will be going through all these questions by yourself, you people will not find any problem. Those students who have completed this task, I will request you to send me, you know, your task and your completed job with me. You have to share it with me, so that I can check कि आप लोगों ने कितना काम किया कितना काम नहीं किया. ठीक है जी. So here we are going to start the next topic. Basically, now entirely we are moving towards lenses. Okay. So when we are talking about lenses, who will tell me, what about a lens? Is the lens a refractive material, reflecting material, total internal reflecting material, or what is that? Yes.
Is it reflecting?
Yes, exactly. Actually, a lens is a refracting material. So if you think that we have to talk about the lens, so you have to keep refraction in your point, in your mind. So basically, refraction of light is the main principle in lenses. Okay. So if I say that in refraction, what was the fundamental principle? What was the fundamental principle in refraction? Bending of light. Isn't that?
Yes.
Bending due to change in medium. Due to change in medium. So if you people just consider that there are two types of lenses. One is the converging lens, and the second one is the diverging lens, what I have to tell you about. And mostly we are asked about the converging lens. So here I will talk that we have to start the converging lenses. Okay.
Okay.
And the second quality or second entity is the diverging lenses. Diverging lenses. So I will start from this one because most of the questions are asked from converging lenses, and very few questions are asked from diverging lenses. But now that is a part of exam, that's why we will talk about these all lenses. So in converging lens is something like this. Somehow, converging lens is something like this. And if I draw some lines which are required to be represented in, so I will label them. This is the principal axis. What is this line? This is the principal axis. Okay, the principal axis, or the main x-axis, you can say. And this is the lens. So if I draw a vertical line which will just cut this horizontal line, then there will be a center. This center is called your optical center. I mean, I will name it C, and where C is your optical center. Okay, ji? This is your optical center. Now, if I draw the light rays parallel to this principal axis, then I will get the light rays to be converged at a single point. Yani these are the parallel rays. I will try to draw the parallel, but uh, sometimes it is not possible to make them parallel. Okay, let's say these are the parallel. So they will converge at a single point here. So this is basically your converging lens. Is it clear to all? The point where these all are converging, this is called your focal point. So what is the name of this one? This is your focal point, or you can also name it principal focus. What other name can be given to it? It is your principal focus. Okay, ji? Is there any confusion in these two terms?
No, sir.
No.
Okay, now we will talk about the focal length. Focal length is basically the distance between F and C. Yani simply speaking, the distance between principal focus or focal point and optical center, that length is called your focal length. So, what is this small f? Small f is called your focal length. So, is this profile picture okay for your lens? Okay.
Yes.
Then there is one more option which is asked. Sometimes you are having this type of question that there is a lens, and in that lens we have uh, principal axis is must in all type of lenses. Then the if the rays are there which are mm, passing through the optical center of this, okay, I have to just ignore it. Let's say this is the ray, and this ray is passing through the optical center of the lens. Then the rays which would pass or which are coming parallel to this one, they are called the oblique rays, and they would focus on a single point here, right? On the focal point, yeah, below the focal point, below the or above the focal point or below the focal point, but this is called your focal plane. This one, because this was the focal point, and this point is also the same as that of the focal point, but that is on the same line. So you can make it either if you are going to incident the light at certain angle, again other than parallel, then this all would be changed, like um, the light ray will be, देखो, if I'm going to incident the light in that direction, right, the rays would be parallel to this one, the ray would be ray parallel to this one, they all would be focused at a single point here, right? So this is how, when you have when you have incident the parallel rays, these are the parallel rays to the principal axis, parallel to each other as well as parallel to principal axis. So they would converge the light at focal principal focus. But if the light rays are parallel to itself, but they are not parallel to principal axis, this is your principal axis, then they will focus either above or below the principal axis, right? So these two techniques will be used for my image formation. Is there any confusion in these two diagrams?
No, sir.
Okay. So you have to recall the focal length. A statement of focal length is asked to you. Okay, ji? You are asked state what is focal length. What is focal length, by the way? It is represented by small f, the distance between.
The principal axis and the focal point?
Uh, okay, principal axis is something different. The distance between principal, sorry, focal point,
Sir,
focal
can we
point,
say optic center?
and optical center, and optical center. Is this clear to everyone?
Yes, sir.
Yes.
Yani the distance between F and C, capital F and capital C. Is there any confusion in this?
No.
Okay. Okay. Come on. Moving on that one. The image formation in a converging lens. Okay. Image formation in a converging lens. In in a converging lens, there will be two properties of image. Please remember this. This is really, really important. if image is real, yani I will just write in another way, just a second. Yani if your image is real, then it would be inverted. Mandatory hai, right? It is mandatory, right? And then there can be two other options. I will try to manage those two options, but here is that if the image, this is the image properties, so image would be real. If it is real, it will be inverted, right? It can be small, it can be smaller, larger, or equal to. So these all are the possibilities. These are the possibilities, but what is not possible, which is eternal fact, that is the image will be real and inverted. So either this or this or this. But this is, yani, this is a fact which will never be changed. So this is 100% sure, right? That if image is real, it would be inverted. Real image will always be inverted. Is this, yani, I'm just going to um, explain this again, that real image will always be inverted. That is why real and inverted are correlated. So real will always be inverted. Is it clear to all?
Yes, sir.
Real image will always be inverted. It can be small, can be larger, can be equal, but it would be inverted. And if the image is virtual, then what will happen? The virtual image will always be that will always be upright. Okay, that will always be upright. So if the image is virtual, it will be upright. So this is, a universal truth again, that virtual image is upright. And one more thing which is mandatory for this, that is, it will be, that is always larger. That's it. तो आपके पास क्या तीन प्रॉपर्टीज हुई virtual image की? Virtual image will be upright and larger. Virtual images, if the image is virtual image will be upright and large. That's it. Nothing else is asked to you. So if I say that how will you distinguish between upright and smaller and larger image? Sorry, this is object, okay, and I'm trying just this arrow, don't worry. This is an object, and if its image is, oh no, that is incorrect image, sorry. Okay, if this is the object, then if the image is of the same height, check this one out, it is inverted and of same size. This is inverted and larger. This is inverted and smaller. Is this all clear? These all are these all are real images. Okay, these all are real images. Is it clear to everyone? Real. This is the object. So this is small. This is equal in size, and this is larger. Is there any confusion? So this will
No.
always be inverted. And if I draw, oh yes, one more thing. Oh, superb. This will always be on the other side of the lens. Yani, this is the lens. So this is the identification mark of the real image, that this is on the other side of the lens. That's it. Is this clear?
Yes,
Ji.
sir.
Okay. But if the image is virtual, there is a identification mark for that one also. For virtual image, if I draw a straight line, then a lens, then this would be, let's say this is a lens. Okay, so if this is an object, the image would be larger and on the same sides of the lens. That's the object, and this is the image, right? And this is your virtual image. So do you see that is upright and larger? Hmm?
Yes, sir.
Okay, so this is always upright and larger. Okay, this is formed only in, and this image is observed only in magnifying lens. Magnifying lens. Okay, but the other images which are real, those all, they can be found in different uh, situations. For example, this one, that is in camera and human eyes. Camera plus eyes. So I believe so that this would be easy for you, that in camera and human eyes, image will be smaller and real and inverted. In your projector, this is formed in projector, this one, and this is basically in photo enlarger, although it is not enlarged, but its function is not that much. That is why we rarely use this image, or we rarely use that type of image, because we observe the same type of you know same size of image, not smaller, not larger. So this is, I will say, that it is less frequently asked to you. But these two, the the real one, camera and eyes wala, and this is for projector wala, they are asked to you. And most probably this magnifying glass wala is asked to you. Okay, now the most tricky part, where you people are always stuck, that is image formation. Okay, ray tracing method. Okay, ray tracing in converging lens. Ray tracing in converging lens, I told you that there would be some rays which would be used to form the image. Okay, I will just draw a lens here, and then I will let you know that how to practice these all rays together. Okay, just a second. Almost this is the center, right? Is it? almost, because I tried to draw the center, but almost this is the center. So first of all, the important thing is you have to draw the optical center. This is optical center, and let's say the focal length of this lens is 2, 3, 3 centimeter here. So this is the focal length. The same way 1, 2, and 3 centimeter here. This is the focal length. Now I will draw an object and then I will draw its images at different positions. Suppose this is an object and that object is of this is the object. Okay, this is the object. Okay, ji? Is it clear to all?
Yes, sir.
Yes, sir.
Okay, once the object is at position number 1, how will you draw the image? Please ensure this all what I'm telling you. This is really important. I mean, I will tell you all the possible methods, and you have to ensure those methods, that whether you are getting those or not. And once you will practice them all, it will be, helpful for you. So here, I'm just going to give you the rays. First ray, what you will draw from the head of this, it must pass through optical center. That's it. Wherever the object is, what you have to do, you have to draw this ray number 1. Is this clear to everyone?
Yes, sir.
Okay, ray number 2 is that ray which will be passing through. Yani, basically, that was first ray which would be unbent. It will never bend. Ray number 2 is parallel to principal axis before the lens in this way, and after the lens it will pass through principal focus. Okay, this is mandatory. Remember this thing, that it is passing through principal focus after the lens. So this is your ray number 2. Then these two rays are enough, but sometime the examiner gives you this ray which is passing through principal axis first, and then it becomes parallel to the principal axis. Yani, sorry, it is passing through the principal focus first, first focal point, and then it becomes parallel this way. So, is it clear to everyone?
Yes, sir.
This is ray 3. So, wherever these three rays would intersect each other, here you will get the object, image of the object. This is image. So, what about the properties of this object? This image. This is the object, and that is its image. So, image is real, inverted, and small. Are you getting my point? बेटा जी, is it clear? समझ आ रहा है सबको? Hello
Sir.
everyone.
जी सर आ रहे हैं।
Okay. Okay. Now I will try to copy that. Oh no. What to do then? There is the copy option here. इतनी देर में मैं नहीं बना लेता ऐसे.
That's what I was thinking as well, sir.
Hmm? Now it is stuck. Now, okay, fine, fine, fine. Okay, now I will draw a single ray, yeah, single diagram, sorry, not a single ray, single diagram, and I will draw all type of objects at the same point. This way, this is the lens, okay, and in that lens, the principal focus is 1, 2, 3, 4. Why? Because this is a thin lens, so when the lens becomes thin, focal length will be increased. 1, 2, 3, 4. So here is the focal length. Now I will draw just one object here. Here is the object. Then I will draw an object exactly at this point. Then I will place an object exactly at this point, and I will draw the images of these three objects. Okay, ji? Ready?
Okay.
Okay, go ahead. Ray number one. Oh, this is so thin. It would not be visible to you. Ray number one will be passing from where? From optical center. Okay, ji? Ray number one will be passing through optical center. So let's pass it through optical center of the lens this way. This is your ray number one. It will be useful for every type of ray here. Okay, ji? Then second ray, I will draw a parallel ray from this position, and then I will draw it from, or I will pass it from optical center. And did you see what is happening? The rays are intersecting each other here. It means I am having the image of this object here below the principal axis. Am I right? Is it clear to all?
Yeah.
Yes, sir.
So, what about the properties of this image?
Inverted.
Okay, what else?
Larger.
It's
Yes,
magnified.
this image is real, inverted, and magnified, or you can say larger. Okay, now I'm going to draw another pair of rays with some different colors. Uh, okay, for this one, okay, it is not visible. It is not visible even for me. Then how will you see that one? देखो इधर से करना है मैंने. So here we go. Yeah. This ray would never change. Only this ray will be changed. This one. Did you notice? This ray is same for every position. That which is passing through origin, which is passing through F. So
Why is
that
that,
ray
sir?
sorry,
How come?
yani the ray which is parallel before the principal axis, it would always pass through principal focus. So it would never be anywhere else. Only the light rays which are passing through optical center, their direction is changed. So here, for this position, you can say no image is formed. No image formed for this position. Why? Because the object is placed at focal length, right? Because object is placed at focal length. So when the object is placed at focal length, there is no image formed. But here there will be a game changer image right now. Okay, ji? The game changer. Game changer mean I told you it would be same. It would be same, right? But what will happen then for this one? Are you getting my points?
Yes, sir.
Okay. Now
But why is it that down, sir? Like the maroon one?
maroon one, you are you are following the rule. The light ray which is entering at the lens or which is passing through the lens in such a way that it is parallel before the lens, yeah, it is parallel to principal axis, it would pass through F, right? And the ray which will pass through optical center, it will never bend. So just draw it
But
according
like,
to these.
why did you make it that huge? Just because it has to reach optical center.
Sorry, can you repeat your question?
So you're just gonna make the one that's passing through the optical center large enough to pass through the optical center?
Yes, it must be passing through optical center by all means. तो
Okay.
आपका क्वेश्चन क्या है?
No, no, I understood. I understood. It's fine.
ठीक है, यानी ray number 1, this is your ray number 1 which would be passing through optical center without bending, and this is your ray number 2 which would be passing through principal focus after after the lens. Now what will you do? You will simply redraw these lines. How? Okay, yes, you will put your scale here, then you will put your scale here, you will join these 2 points. Please mention, sorry, please note down that I'm joining these 2 points. Now I will redraw my line in this way, ये देखो. But don't leave these 2 points. If you will leave, or if you will join any of the single point, your image will be at a different position, so your these 2 points would be joined together. Then place your scale at this point and head of the object and just draw it behind. Now did you see where the images are intersecting each other? Sorry, where the lines are intersecting each other?
Yeah.
Okay, so at this point, what you have, yes, you have an object, sorry, the image in this way. Am I right? Isn't it bigger one?
Yeah.
So that is why this image is basically virtual, because you have drawn the lines were not there, you have drawn the lines virtual, upright, and magnified. And that's the reason it is used in magnifying lens. Is this clear to all?
Yeah.
Okay, then the last image, which is basically on the diverging lens, I will try to draw the diverging lens. Mhm. It
Sir,
would
what does the question ask you for? Like, what
nothing.
does it already provide?
हाँ हाँ, बोलो
What does
बोलो.
what does the question already provide? Object already दिया होगा?
हाँ हाँ, object is given to you. You have to draw it. Ray tracing method है ना. क्वेश्चन देखे नहीं आपने कभी इस तरह की?
सर, लेकिन कुछ questions होते हैं जिसमें object नहीं दिया होता.
हाँ, ऑब्जेक्ट नहीं दिया होता तो आई टोल्ड यू ना कि व्हाट यू हैव टू डू, यू हैव टू जॉइन द पोजीशन ऑफ इमेज. ये देखो, what you have to do, you have to join the principal focus and this point and draw the ray, and then this point, and if image is given, join the head of the image, and where the ray is this, where this ray is intersecting, आप वहां पे ऑब्जेक्ट को ड्रॉ कर दो.
ठीक
And
है.
if object is given, join the optical center and head of the object, and where the rays are intersecting, there the image will be there. ठीक है?
ठीक है.
Yeah, this is very important thing to know. Now I will try to draw converging lens. Basically, I'm trying to draw the converging lens for a long time, लेकिन मैं कुछ draw नहीं कर पा रहा हूँ from my software. Anyhow, let's consider it as a diverging lens. Suppose this is a diverging lens. I will just draw it from the edges. Its edges are thick from here. Let's say thick from here and thin from the center. Oh my god, इतनी बुरी ड्राइंग तो मेरी नहीं थी कभी वैसे. ये आपका diverging lens. Okay, now what you have to do, wherever the object is, let's say the object is there. Here is the object. ठीक है? Oh, ये तो double headed object हो गया. Oh my god. Here is the object.
It's still gonna be double-headed, sir. You have to go up in the customization tab and remove one of the arrows.
Okay, sir. Now it is. Huh?
No, sir, you have to change it. Yeah, you can
Probably
change whichever one.
this one.
जी. सर आपको क्लिक करना होगा वो छोटा arrow tab जो है ना. Yeah.
Oh, खैर, leave it. It is time wasting now. Okay, I will rearrange that. I think so. मैंने कुछ गलत कर दिया है. Now the problem is, what will you do? You will draw the lines at the same rule. Same rule. There is no different rule for this one. Then what? How to draw the lines? First line or first ray will be passing through optical center this way. The second row or the second line will be parallel to the principal axis, and now you will definitely your principal focus will be given to you. Let's say its principal focus is over here. Now you will join your scale here and here, and then you will divert the light ray in this way, right? This lower part would be basically dotted one. ये वाला सारा dotted होगा. This one will be dotted one. Okay, this one will be dotted one. Now wherever you are having the intersection of these two, here you have the image, right? Here is the image form. Okay ji?
Sir, this is virtual, is it?
Yeah, definitely it is virtual. So it is upright now. ये इसको मैं थोड़ा सा सेट कर लेता हूँ. Basically it is virtual, upright, okay, and diminished. In diverging lens, wherever you place the object, the image will have the same properties: virtual, upright, and diminished. There it was virtual, upright, and magnified. Here it will be virtual, diminished, upright, and diminished. So these were basically the concepts of your lenses. I will try my best to reinforce them all. Again, if you people will try the questions, they will be, then you people would be able to know the problems are still there or not. Okay.
Got it, sir.
Okay. Any question?
Not yet.
Please do the questions. आप लोग फंस जाओगे, मैं बता रहा हूँ. I will never come back for the third term. ठीक है ना? कि टॉपिक आपको तीसरी बारी भी समझाऊं, it would never be possible. क्योंकि आगे टाइम नहीं है। देन आई विल कम अक्रॉस योर प्रॉब्लम्स, जो भी आप लोगों के इश्यूज होंगे आई विल सॉल्व देम। तो प्लीज आप लोग टाइम निकालें, मैनेज योर टाइम। थोड़ा बड़ी घड़ी ले लो ना, बड़े डायल वाली। ऐसे ही है ना अरीबा?
Yes.
बड़े डायल वाली घड़ी का मतलब ये होता है जिसमें टाइम ज्यादा हो थोड़ा।
If only.
36 आवर्स का डे हो जिसमें।
Seriously,